Hello everyone, in this recording we'll go over some more realistic examples of linked brushing. So the applications are going to be a little bit more sophisticated, but remember it's the same kind of structure used across all of them. Right? We're going to have a reactive value that's going to see which of the points are currently brushed over. We're going to check whenever the user is brushed by using an observe event, and then our render will depend on the reactive value and it's going to regenerate every time the selected brush points are changed. Okay, so what is going to be the first example? Let's look at the IMDb dataset from before, except instead of using a slider to figure out the time range, we're going to use a histogram. So let's think about how it's going to work. So here's just a histogram of when the movies were released. So this dataset has a whole bunch of movies from the 2000s. There's some movies from before 1960. There are some mistakes, it seems like, where they're movies from the future, but it's just a histogram of when the movies were released. Right? And the idea is every time the user is going to brush this histogram, we want to highlight the corresponding plot or corresponding points in the ratings plot. Okay, so this is just linking a histogram and a scatter plot. We're going to condition the points shown in the scatter plot using the histogram. So how do you actually do something like this using brush events? This is the main logic. So we're going to add a brush to the histogram. This is the name of the brush. I'm using this direction equals x argument so that it doesn't really make sense to brush the y-axis on this histogram. You really only want to brush the year. So I'm forcing it to brush only the axis. So that's how I've changed the UI. What is going on in the server? I begin by selecting all the movies. So it's just a vector whose length is equal to the number of movies. Whenever the user has brushed, so we're going to observe whenever there's a plot brush event, then we're going to change this vector of selections using this wrapper reset selection. It's going to look just like the reset selection from the previous penguins example. That is going to trigger a change in reactive value. Whenever the reactive value gets changed, then all these outputs are going to change. So we're going to have a histogram, it's going to change. We're going to have scatterplot and a table that shows all the movies that are selected. Okay. That's the essential logic. So I'm not going to copy all the code because it gets too much code in one set of notes. You can look at it by following this link. Here's an example of the interface. So if I want to look at all the recent movies, it's here. And look at all the older movies, it's here. I like this example because it shows that there's a kind of selection bias. Right? It's not that movies have gotten worse over time, but it's probably more likely that the movies that get included in the database from a long time ago, those are probably the better movies. But just play around and look at how the ratings change over time. So that's one way that you can link these two plots. An even more sophisticated approach would try to allow you to brush both of them. Right? So you could imagine wanting to brush certain ratings and look at what are the years corresponding to those ratings. It's going to be a little bit more subtle than what we've done so far. We can't just highlight or unhighlight because there's a histogram. It's not that we don't have a point for every single movie in this histogram. So how can we approach it? The idea is we're going to change the transparency in our histogram. Right? So this is the entire code. I'm going to skip over the code so that we can see. Okay. So the idea is that if you've selected, here is just I picked the first 500 movies. I can generate a new histogram for just that 500 movies without losing context of the original histogram, just by overlaying these two geom bars. The one of the selected counts, these sub counts, is going to be the darker one. And then this background of all the movies, that histogram is always going to be shown as this light gray one. So now let's think about how would we make sure that we can update both plots. We're going to need a new Shiny app. Okay. So this is what it would look like. Just the high-level logic. So before it was a brush just on the histogram. Now we're having a brush on both the scatter plot and the histogram. And then how do I update things? I'm going to check for whether either the histogram or the scatter plot were brushed. That's why I'm using the exact same ID in both of these brush objects. When the user has brushed, we're going to reset the selected, and it's going to be a selection based on either the scatter plot or the histogram. But that's going to change its reactive value, which then triggers a change in all three of these outputs. Okay, so let's look at the app. So I can select these movies, it shows up on the scatter plot, that's the same as before, but now I can also select the ratings, and it shows the years for the movies within that rating group. You get different ratings and you get different years. And it's also showing the original movie names. Okay, why is this kind of interesting? I like that even though the interface looks the same, right? Each plot and its position is the same as exactly before. But now that we have brushes on both plots, we can actually answer a different set of questions. And so we've generalized the class of queries that we could answer just by adding new interactivity. Okay. The final example, we're not going to use the movies anymore. Let's look at this dataset on flight delays. So the way it works is we have a whole bunch of flights, we know when it was, we know when it was supposed to depart, and we have when it actually departed. Right? And you want to see, are there factors that make a flight more likely to be delayed or not? The thing that makes it tricky is that there are a whole bunch of variables that are potentially related to whether the flight is going to be delayed. So let's look at that. Our idea is let's have separate histograms. One histogram for, we're going to do 3 variables just for this. And when you brush over all the flights that belong on one range of the histogram, I want to highlight what is the corresponding conditional distribution for the other histograms. So at least on the UI, we're just going to have these 3 different histograms. Right? Since we don't really care about brushing the Y on a histogram, each of them is this direction equals X type of brush. This is the code that's going to update our histogram every time we've made a new selection of flights. So this argument, this is going to be which kind of subset of flights have we zoomed in on. So it might be all the flights that leave before 7 in the morning, for example. And then this V is just which variable are we looking at? Right? Are we looking at departure time? Are we looking at the time that, the distance that the flight is going? And just like before, we're going to overlay these 2 histograms on top of each other. We have the one histogram, which is this background, which is the same for every single selection. And we have this sub-flight sub-histogram, where it's the ones that are corresponding to the selected flights. So let's just look at the example, right? So these are the flights that were really, really delayed. You can see they tend to have a little bit later departure times. Okay. So if you're wanting to get early, or you want no delay, it's actually a little bit better to get a flight that's departing early in the morning. So we can check that alternatively here. Right? So the ones which are early in the morning tend to have not so much delay as later in the day. See the tail actually, the tail extends a little bit further on.